we're going to look at are the following. We have already, you don't have to write all these things out. A lot of these models are going to be given to you. The ones that you'll probably spend the most time having to reuse is going to be your growth and decay models. Gaussian model. Logistic growth model. We did logistic growth last year in honors. I don't know if they did it in Algebra 2. That was the model that increased really fast and then it tailed off. Okay, so there was something like that. You probably didn't do that in Algebra 2, but I know we did in honors. And then the logistic growth models, or excuse me, logarithmic growth models. A lot of these things are going to be models that are going to be given to you. They're not going to be a lot of stuff you have to come up on your own, except for usually growth and decay, as well as, principal interest style problems. But remember, you have a note card. It's one of those things that it would not be a bad idea to remind yourselves to have on there.
Right, what on a note card?
Your growth model stuff. This is all right in the book on 257. This is all right out of the book on page 257. It's a nice little blurb. Remember, a lot of the things that are on there, what things stand for. What's that? Like I said, a lot of the weird models will be given to you. The ones that I'm more concerned that you remember how to use are going to be your growth and decay. When you have your initial amount, or your principal, what's your rate, your time, things like that. You should be able to do those. A lot of the other ones will wind up giving you. One of the things that does show up in this unit, I shouldn't say this unit, but in this section, is the talk of like how you can double, or how long it takes to double your investments and things.
So is A like
Initial amount.
the initial?
Yeah. A's are, if you, all right, just so you know, y equals a e to the, that's your initial amount. Think of this as principal is an initial amount, e to the r t. That's continuous. That's compounded continuously.
Oh, so
It's kind of the same idea. This is your compounded. That's your compound continuous. It's just a growth model. Okay, that was back in 3.1. 3.1, I think. 3.2, somewhere along those lines. No, it was 3.1. Sorry. 3.1. Right here. Compounding. The other thing I want to look at was, I'll go back to it. That's your rate.
Wait,
They use different letters sometimes. For example, let's look at this. Let's say I have an initial amount. Say I have an initial amount at $800, and I'm going to annual interest rate of 3.5%. The amount. We'll talk about it. So this is your. This is going to be a continuous one. I'm going to say it's compounding continuously. So we have our principal, which is your initial, and this is what you want that you'll get at the end. That's how they wrote it up in 3.1. It mirrors similarly to what they had in this one, but they changed where the A went. This book does this all the time because a growth model, an exponential growth model, you can change from like it's your initial amount, that's what they just call it with the A, as opposed to your dollar amount that we looked at it with per. It's one of those weird things that this thing does. Now, I want to know how long will it take in years to double. So if I want to figure out how long it's going to take to double, end? What do I want my amount to be in the end?
16.
Good. My amount that at the end that I want it to be would be 1,600. So it'd be 1,600. What's my initial amount? 800. What's my rate as a decimal? 0.035. Good. T for time. What do you do?
Divided by 8.
Divided by 800. And then what? So you natural log it. So you get the natural log of 2 equals 0.035t. And then what? And that'll tell you the amount of time it takes. It's a very common problem. Okay? It's a very common problem. From there, it's just pressing buttons. So let's see, what do we get? What do you get? What?
We should figure out the exact
Oh, yeah.
day.
No, we should.
So we have calculator. So I have what? The natural log of 2. And divide that by, was it 0.035? So approximately 19.8 years. If you round to the closest year, how long will it take you to get double your money?
20 years.
And 20 years. About, remember that? Double squiggly?
Yep.
Double squiggly means approximately 20 years. What's that?
I use double squiggly all the time. All your time.
Very good. What if we work the other direction? Let's see if we can do this. Let's say we have an initial amount of $500. And then after, well, let's see. We'll make it a real problem. Let's say you're in kindergarten and your grandparents put $500 in an account for you. Some account, yeah, me too. And then after, what would that be, 13 years after you graduate?
Yes.
Let's say after 13 years, you got $7,000. Wow. I don't know, I'm just making numbers up.
That's actually a really good rate.
It's a pretty good rate. Let's say it's compounded continuously. What was your rate?
Hey, when I just listen, it's like this compound continuously, right? It says that you put in $500, right? That's compounded continuously. Does it keep on taking money out of their account? Is it adding on, or is that the money just keeps on going?
That's the money that's already initially in there. What happens is, as money, all right, when you have interest, you're paid whether it's continuously, quarterly, semi-annually, monthly, one of those things. And as you compound interest, the more you compound it, the closer it approaches that value of E. That's where that E value comes from. That comes from, E is about, it's 1 plus R to the n as n goes to infinity, okay? I think it's 1 over n, I believe, but it's getting to this value of 2.17 or whatnot. That's where this comes from.
Okay.
So the more it's compounding, the more it's approaching this E value. That's why it's not coming out of your grandparents' account.
That's what I was wondering.
It's like the bank is giving you money for putting your money in their bank. So if I give the bank, yeah. So if I give the bank $100 in the savings account interest rates are like 2%, not even 2%. It's really low. They're going to give you a percent back every year. So after 1 year, I'll have $101. After the next year, I'll have $102.10 because it's building on what's on there. It recalculates on the new principal. So as it calculates the principal grows. That's how you grow a bank account. That's how it's working. Sir?
And for, you say that after the year, is there like a certain date, like where you can put money before, and then I guess doubles up?
What do you mean? For like, is this, so if I put in $500 right off the bat, is it frozen, I can't add to it again later?
Well, no, yes.
Okay. When you start an account, it doesn't matter. Most accounts you should always be able to add to. But as far as withdraw, sometimes you get penalties, like certain types of savings accounts, like 401ks, 403bs, IRAs. You can get penalized if you withdraw from it before its maturation point, I believe they call it, or before it reaches maturity. You know, for example, as a teacher, I don't get you've heard of 401k, correct? As a teacher, I'm a public employee, I don't get a 401k. I don't have Social Security, right? I pay into what's called a 403b, which is a different type of retirement just for teacher stuff. So I can't, excuse me, I can't touch that account until I've retired, but at a certain age. So
Yeah, that's like 60.
it's kind of like that. But I can always add more into it.
Well, will it reset?
With the on top of the principal? Yes. Yeah. Like for example, you know, I had X amount of dollars in a 403b. I had a 401k from a previous employer. I took all of that 401k money once, obviously because it was just sitting there. I wasn't adding to it. It was just growing interest. But at some point in time, I transferred it to my 403. That way, my 3 account had a bigger principal that'll always be adding to it, and the amount that's in the account will continue to grow at a higher rate.
What's a fourth rate? I don't know, it's like slightly better.
401 is more is like an anybody except for public service.
Fourth rate.
Correct.
So what's a public service job?
Teachers,
That's it? Mail.
mailmen, things like that. Because I don't pay into Social Security because I'm public service.
We just learned about Social Security and stuff like
Even though I paid Social Security for so many years before I got that, but I'm going to be able to receive any of that because of teachers, but whatever. So in this case here, what you guys get for your rate?
that. 20.3.
20.3%?
Can I go to that bank?
I would love to go to that bank.
Bank sounds awesome.
That's, what's that? What do you get, 20.3? So what you're using, you were doing a compound continuously. So
I
we're
got
gonna use,
the answer.
we're gonna use our amount. It's gonna equal the principal, the original amount. What we're gonna end up at the end is $7,000. We started with 500. We wanted to figure out our rate after 13 years. Okay, so I divide up by 500. 70 over 5, which was 14. Then I take the natural log of 14, and then I divide it by 13, and that'll give me my rate.
Then you have to
70 divided by 5?
then you have to times the answer by how much was right.
Yeah, because that's just a decimal. Yep, that's all. So like I said, a lot of these things are really, really, really straightforward. The other style that we're going to throw in here, this one. We'll do this one. Like a population growth. The population of fruit flies is increasing.
No, we did this. I remember this problem from last year.
Really?
Yes, I remember fruit fly problem.
There's probably
No.
like
I remember bacteria
Yep.
Bacteria, yes.
Yeah.
But I do remember fruit flies.
they're this. Hey guys, I don't know if you've quite figured this out, but pre-calc is algebra 2 with a couple extra word problems.
You're a liar. Pretty much.
Yeah, it's nice.
It's nice.
We haven't gotten a tree yet though, so.
We just
We're gonna drop our.
Well, let's start next week.
Oh, nice.
See ya. So what we're going to look at when you do the excuse me. Let me pull up the. Oops.
You're pretty cool.
what I'm going to do here is use their version of a population growth and show you how things get substituted in. Okay?
Oh, is that like the?
Yeah, it's like their version of that. So what they're saying here is we have a growth model, so we're going to use that y equals a, is some initial amount, e to this b, which is your rate times x. And think of your time as your b value. Okay? Think of time as your b value, or I'm sorry, as your x value. Because if you look at it, this was our initial amount, which we call principal to the rate times time. If you want to think of it in terms like that, it's kind of helpful what you're going to put for what. Okay. What's up?
Didn't we like do the PE like RT earlier in the chapter?
Yeah.
So why did they switch it like now?
Because you can use it for a growth model as well, but they're just using different values. Okay. That's all. So they're saying some amount after 2 days was 100 flies, after 4 days there were 300 flies. So what I want to look at is after 2 days, we had 100 flies after 2 days. But we need to figure out what the initial amount was to start with. After 5 days, we had, what was it? Oh, excuse me, after 4 days, we had 300 flies. What's that?
Yeah, because you can't.
Oh, sorry, I flip-flopped it. I'm sorry.
That's okay.
Don't say it. But no, that's not what I meant. Don't you need something else to figure out the answer because you can't have
No.
two decimals?
Well, you can't, yeah.
Because think about this. We have two variables, right?
Yeah.
Can I use substitution to substitute one in for another?
Oh, because
Yeah, but what are
it's
you
two is fine.
If I want to get a by itself here, don't I just have to divide by e to the 2b? So 100 over e to the 2b is a.
But what's B?
What? Okay, we need to.
So that's the answer?
No. And we did these problems last year too, when we did logarithms.
No. Oh.
No, I'm sorry, not logarithms. We did this with sequences and series, when we had to find that rate value and we had to adjust back and forth. So what I'm going to do here is take this, I'm going to substitute in here for a. How do I get that? What's that?
The E's and the two B's cancel out? No.
Well, there's supposed to be a 4, that's why. Okay. Nothing's canceling themselves out. But I want to show you what happens here. Now, you have 300 equals 100 e to the 4b over e to the 2b. With the e to the 4b over e to the 2b, do they have the same base? Different exponents though, right? Play war, who wins? On top, so what's 4 minus 2? 2. So this simplifies out to be 300 equals 100 e to the 2b. How do you solve for b now? You divide out, and then you want to take the natural log. Divide out by 100, we're going to get 3. Natural log it, and divide by 2. That gives me my rate. Okay. That'll give me my rate. And just you can leave it as a decimal. All right. So when you do that, we get natural log of 3 divided by 2.
055. You messed up.
So we get 0.055, oh sorry, 0.55. Which means if we want to know how many were after 5 days,
Oh my gosh, this is annoying.
Wait, but what's the,
we take this to your initial amount, 100.
oh my goodness.
It's a couple of a step equation, guys. It's not like it's really difficult. Take 100 divided by e to the 2 times 0.55. It's all calculator. E. I did not hit control, did I? There we go. So there's your initial amount. And I'm going to say that I can't have a decimal amount of flies.
Can't have half of it. There's a decimal, you of course.
Well, for our sake, let's say we don't have a decimal amount of flies. Okay. So I have my original amount then would be 33 flies to start with, and then I just go back and put it substitute back in.
33 e to the 0.55 times 5.
Correct.
So you get 560.
There you are. So now we have, what we had to do there is use substitution to figure out the rate. Use that rate to go back to find the initial amount. Use that initial amount to then figure out what it was going to be after so many days. There are more than one step to these types of problems. They're not difficult. This is about as crazy as some of the ones are going to go. But that's the idea that you're going to use, okay? So finally then, now we know what our initial amount was, what our rate was. We had to do after 5 days, so it's going to be 33 was our initial amount. E to the rate of 0.55 times 5 days. And what did that give us?
560.
516 flies. It is IES, isn't it?
Yeah.
Yeah.
I only deal in X and Y's.
And
Not
A's,
flies.
and A's and B's and C's and I's and E's
That was my
and I's and J's.
It's not just a bunch of flies.
Okay, all right. So thanks, jerks. Like I said-
So many, there's like a variable for each letter, or something for each letter.
There's a variable.
Yes, there is a variable for each letter.
That's not what I meant.
That's what you said.
There's a variable.
But then I changed it myself.
No.
Or I
Daddy.
corrected myself.
Let's see. So this one was given to you, 35 is given to you, 18. Straightforward, 38, you're given a model, 40, you're given a model, 43, depreciation. Okay, you're given the model, 45, you're given the model. I do not see a single problem for tonight that you have to come up with your own model, so you don't have to worry about something that crazy. Everything you're doing tonight for the weekend is all straight. There's nothing you got to come up with your own model like that. As you go into the second day, 46, have that, 48, have it, 49, you have it, 51 in my head. Hey, real fast, in number 49, if you check your book there,
That's the next.
I know, but I want to make a note in case you guys get rambunctious and you feel like doing more of this.
Yeah.
Who doesn't?
That's funny.
That's all right, I was
He's
like.
like, never shot down.
Anyway, the x-axis is in months. It's mislabeled, it's supposed to be in months, not years.
The book messed up.
Books never make
The
mistakes.
book, our geometry book used to. Mr.
According
Murphy,
to
what's your
Mr.
email?
Moscona.